Picture the system we built last episode. It's live. Real people are asking it real questions every day. And for the last 3 weeks, it's been wrong. Nothing crashed. Nothing threw an error. The answer just quietly went bad. Confident, well written, completely incorrect to a slice of the people using it. And nobody noticed. Zero errors logged, uptime 100%, every dashboard green for real weeks straight. This is the failure mode nobody prepares for. AI systems don't crash, they drift. And the monitoring you are already have has no idea it's happening because it was built for software that breaks loudly. Forthing would have catch this on day one and all four run on the same system we built in episode 1 and episode 2. Trace every run, keep a frozen set of test questions, treat freshness as a number you watch, and pin every release you can undo it. So why is this so hard to see? Because normal software fails loudly, a service goes down and you get an exception, a stack trace, a 500 something wakes somebody up at 2 in the morning. An AI system that's gone a bad return a 200 success, a clean, fluent, confident answer that happens to be wrong. Latency normal look, error rate is zero. Token spans is normal. Everything you are already watching say the system is fine. And here's the reason. Every dashboard you have measure whether the things responded. None of them measure whether it was right. Those are completely different questions, and only one of them has ever been on your screen. There are three ways this happens quietly, and I build this system so I have watched all three play out. One stale retrieval, your document change the index, that's the searchable copy your system actually looks in didn't. 2. The model changed your under you. The provider shipped an update, same version string in your code, different behavior in production. 3. Somebody edited the prompt one line on a Friday, no review and no record anywhere of who touched the three different cases. One identical symptom, your answer get worse and every green light stays green. So let's fix it one move at a time. One move. Trace every single run. A trace is a recording of one full run. Every step the system took to produce one answer the question that came in, which documents got pulled, how old each one was, the re-ranker score, every agent step from last episode, and the answer it finally gave. Most teams log latency and token count that tells you the pipeline run. It says nothing about what the pipeline actually saw and what is the whole diagnosis. Two fields matter more than everything else: the content that got retrieved and the age of that content. With those 2 or 3 weeks, mystery turns into 5 minutes with a log file. You open one bad answer, you see the document is used. You see the document is from March. That's it. Investigation over. Without those fields, you are guessing, rerunning prompt by hand, trying to reproduce something that happened to a user 11 days ago. You can't debug a conversation you never recorded. That's the whole rule. And of the four moves, this is the cheapest one to start today because it's just writing things down. Move 2, a frozen set of test questions. Take 50 to 200 real questions, real ones from the real user, and write down the answer you know is correct for each. That's the your evil set, and you run it every time anything change. New model, version, new prompt, new retrieval settings. The word frozen there is doing a lot of work. The moment you start editing the questions to match what the system does today. It stopped being a measurement, it's just a mirror. Here's the part almost nobody does, and it's exactly the part that would have caught our 3 weeks. Don't only watch the average score, count the flips. A flip is a question the old version got right and the new version gets wrong. And you can have both at once. The average score goes up, 12 cases that used to work quietly stop working. Researchers have a name for these navigate flips. Apple published a paper measuring how often a base model updates break things that used to work. So your dashboard tells you the model improved and it's telling you the truth. On average, those 12 users would strongly disagree and they are on one who quietly stop coming back. If your stomach just dropped a little hit like it helps the reach the other people running the same system right now who have an no idea it's now happening to them. Move 3, freshness, is a number you watch, not a job you run at night. Your search turns into question into numbers. It turns every document into numbers. Then it finds the one closest in meaning. Those numbers are called embeddings and they encode exactly one thing, meaning. They do not encode time. There is nothing in that number that knows when the document was written. So, a beautifully worded document from March beats a slightly clamorous one from last week every time at high confidence. That's the failure in one sentence. Your system is confidently right about meaning and completely blind to time. Measure it, not the age of your index overall, the age of the document that actually get retrieved and used. That's the number that starts moving before any user complains. And reindexing, when documents change not on a nightly cron, a schedule assumes your data changes on a schedule. It doesn't, it changes when somebody edits a policy on a Tuesday afternoon. Move for pin it, get it, and make rolling back boring. Three separate things change how your system behaves: the model version, the prompt, and the retrieval setting. If those shifts independently, you can never answer the only question that matters during an incident. What's changed? Bundle them. One pinned release model version and prompt and retrieval config locked together and shipped as one thing. Then roll it out to a small slice of traffic first. That's a canary 5% of users and you watch what happens and put the evil set in front of it. The new version runs the question. If it fails, it doesn't ship. No debate, no override, no shipping it. Anyway, because the more demo is the on Thursday. Then the last piece, going back, has to be one boring command. If rolling back needs a meeting and two approvals, nobody rolls back. They debug in production on live users at midnight. Cheap rollback is what lets you ship confidently. It's the thing that makes the other three moves safe to act on. Finding the problem doesn't help you much if fixing it is terrifying. Now, the part I actually want to leave you with, everything I just described sounds like it needs a platform and a team. It doesn't. Here's the smallest version that gets you most of the value. One person, one afternoon this week. 30 questions in a spreadsheet with the answer you already know are right. Every run appended to a plain text file. The question, the documents it retrieved, their dates, the answer, and your model version written down as a string in your config. So it can never change unless you choose to change it. That's one afternoon, and it would have cost our 3 weeks on the first day. Most teams buy the observability tool before writing a single eval question, so the tool ends up measuring a system nobody is defined correct for. I'm building this whole system across the series, one layer per episode, the reg stack, the agent team, and now the oak layer that keeps them honest. If you want the rest of it, subscribe. So here's the whole thing with the ops layer wrapped around it, the reg stack from episode 1, the agent team from episode 2, same system, still doing the actual work. Every run writes a trace. Your traces are where your evil questions come from. Because your users write better test cases than you do. The evil set feeds the gate. The gates protect the release, and the release is one pinned thing. You can undo it a second. Each piece closes a loop on the one before it. That's the ring. None of this is clever. It's the boring layer that makes the clever layer trustworthy. Three things to take with you. One, green means it responded. Green has never meant it was right. Two, average hide the regression you care about most. So count the flips, not just the score. 3. Freshness and version pin are oops problem. No smarter model is going to fix either one for you. So tell me in the comments what's the longest your AI was quietly wrong before anyone caught it, and did you find it, or did you user have to tell you? I want to know how bad things actually gets out of there. And if you haven't seen the first two, start with episode 1 on the reg system, then episode 2 on the agent team. This is the layer that keeps both of them honest. See you in the next one.